Hi guys, so today I'll be explaining the chemistry Ams quiz of term 2 week 4. Okay, so an electrolyte passes through a concentrated aqueous solution of potassium iodide. So since it's aqueous electrolysis, we're gonna do the questions at the anode and the cathode. Okay, so we have a concentrated Ki potassium iodide, and they want the two half reactions that take place. So at the anode and the cathode. So let's start with the anode. Okay, so the first question is the anode made of Cu or Ag? Did they say that it's made of Cu or Ag? No, so we're gonna ignore that. Since it's no, now we're gonna ask, is it made of concentrated I, Br, or Cl? Okay, here they told us it's concentrated Ki, so K and I are concentrated, so iodide is concentrated, so that's correct. So it's yes. So the formula at the anode is gonna be 2x minus to give x squared x2 plus 2e minus. So we're gonna replace the x with I, so it's 2i to give I2 plus 2e minus. So that's the equation at the anode. Okay, so now we have to find the equation at the cathode, the half reaction. So cathode, the first question is, does the solution contain Cu2 plus or Ag plus? Here they didn't say no, it's made of Cu or Ag, so no. So the equation is 2H plus 2E to give H2. So that's the equation at the cathode. Okay, so let's check the options. Cathode, 2H, yep. Okay, so the first option and this option. Okay, so first and third. Which of the following are two half reactions of the electrolysis of molten NaCl? So since it's molten electrolysis, we're not gonna do the questions. We're gonna do the thing where it's like at the anode, we're gonna have oxidation, so non-metal, and at the cathode, we're gonna have reduction, so metal. Okay. So NaCl is Na plus and Cl minus. Na is the metal, so it's gonna be at the cathode, so Na here, and Cl is the non-metal, so it's gonna be at the anode, so Cl minus. And now we're gonna do the half reactions. So oxidation is the loss of electrons, so electrons are gonna be on the products. So Cl minus gives Cl2 plus electrons, and we're gonna balance, so 2Cl and 2Cl, so here it's 2 minus and 2 electrons. Okay, so that's the half reaction at the anode, so anode. And at the cathode, we're gonna have reduction, so the electrons are gonna be in the reactants, so Na plus 1 electron, so E minus, to give Ne. So that's the half reaction at the cathode. So let's check the options. Anode Cl, okay, so this one, and cathode Na, this one. So the last two options. Inert electrodes are connected to the terminals of a battery, then immersed in molten Al2O3. So since it's molten, we're not gonna have the questions. We're gonna do the cathode and the anode. Anode has oxidation, so non-metal. Cathode has reduction, so metal. And then Al2O3 is Al plus, I think, no, 3 plus, and O2 minus. So Al is the metal, so it's going to be at the cathode, so Al 3 plus, and the anode is at the, like, the oxygen's at the anode, so O2 minus. And here they want the overall reaction. So first we're gonna find the half reactions of the anode and the cathode, and then we're gonna add them up. So since the Al is the cathode and its reduction, the electrons are gonna be in the reactants. So 3E minus plus Al3 plus to give Al. And then at the anode, we're gonna have electrons in the product, so O2 minus to give O2 plus 2 electrons. And since here we have two O's, we're gonna add a 2 here. So that's gonna be 4 electrons, so we're gonna change this to 4. Okay, so let's put them next to each other, so like 2O2 minus, to give O2 plus 4E. Now if we're gonna add the reactions, we have to make sure that the electrons are the same number. So we're gonna have to multiply the first reaction by 4 and the second reaction by 3, so the electrons can be 12. So for the first one, it's gonna be, wait, let me make some space. Okay, first one's gonna be 12 electrons plus 4 aluminium to give 4 aluminium, and then under that we're gonna have 6 oxygen to give 3 O2 plus 12 electrons. And since the electrons are on opposite sides, we can cancel them. And then we're gonna have 6 O2 minus plus 4 Al, 6 O2 minus plus 4 Al, 3 plus to give 4 Al plus 3 O2. Okay, so now let's check that in the options. It's this one. Yeah. So the last option. Which of the following are advantages of fuel cell? So a fuel cell is like, it's like something like this, kind of like, okay, and then it like basically produces water and energy. Okay, so the hydrogen comes from here and the oxygen comes from here, and then it releases water and energy. So to use that energy, we could like maybe like add like a light bulb. That's a light bulb, or we can add like a motor. Okay, and it has many advantages since this is like renewable. It's a renewable way to get energy without releasing carbon dioxide, and it has many advantages. And some of them are that it releases water, and again it doesn't release carbon dioxide, and it doesn't really produce that much pollution. Okay, so let's check the options. It produces water, does not produce carbon dioxide, and reduces pollution. What is the oxidation number of Cl in HClO? Okay, so this is the oxidation number, so you're gonna have to remember the rules. Okay, so Cl, its oxidation number is always -1, except when it's with oxygen or fluorine or fluoride. Okay, F. Here, because it's with oxygen, we're gonna have to find it. So we know hydrogen is always +1, so 1 plus Cl x, since we're gonna find it, and then oxygen it's -2, so -2. I'm gonna make that equal to 0. So x minus 1 is equal to 0. Oxidation number of Cl in this compound, I think, is +1. Okay, wait, let me explain again. So chlorine or chloride, or like Cl, okay, it's always -1 except when it's with oxygen or F. Here, since it's with oxygen, we're gonna have to find it by solving. We know hydrogen is always +1, so 1 plus Cl x, since we don't know what its oxidation number is, and then we're gonna add the oxygen, which is oxidation number is -2, and then we're gonna make that equal to 0. Okay, so x minus 1 is equal to 0, x is plus 1. Which of the following are definitions of oxidation and reduction? So before you really read the options, you can just cancel out the options that say reduction number, because we didn't take that. We only took oxidation number. And if you remember, reduction is when the oxidation number decreases, so oxidation number decreases, and oxidation is when the oxidation number increases. Okay? So process in which oxidation number of an element increases is called oxidation, that is correct. Process in which the oxidation number of an element decreases is called oxidation, no, it's called reduction. So it's these two options. Given the following redox reaction, which of the following is being reduced? So again, reduction, or reduced, is basically when the oxidation number gets decreased. So we're gonna have to find the oxidation number of each element. Okay, so in Cr2O7, we know oxygen is always minus 1, so minus 2. And then Cr, we're gonna have to find it, so 2x plus 7 times negative 2 is equal to negative 2. So we added the 2x because we have 2 CRs, look here 2, and then we did 7 times negative 2 because the oxidation number of oxygen is always minus 2, and since there's a 7, we're gonna have to multiply the 7 by minus 2, and it's equal to minus 2 because that's the charge of the ion. Okay, so 2x plus negative 14, or 2x minus 14 is equal to minus 2. I'm gonna put that to the other side. We're gonna get 2x is equal to 12, x is equal to plus 6. Okay, so the oxidation number of Cr in this compound or ion is plus 6. And then Fe, since it's alone, its oxidation number is equal to its charge, so plus 2. And here, we don't count the hydrogen. And then here Cr is plus 3 because it's alone, and when the ion or element is alone, its oxidation number is equal to its charge, so plus 3. And then here Fe again, plus 3. And we don't... Okay, so let's check which oxidation number got decreased, because we're checking which ones got reduced. So Cr2 went from plus 6 to plus 3. Okay, there you go, we found the answer. So Cr2O7, that got reduced, but if you want to check, you can check. Oxygen, we didn't count it because there's water, and we don't count water. Water, like H2O and OH or H, we don't count them when we're checking for the oxidation. Fe went from plus 2 to plus 3, so it got higher, so that got oxidized, not reduced. So خلاص, we just got our answer. It's Cr2O7. Oh, I didn't put the answer? Cr2O7, okay. Hydrogen fuels work like batteries, but they don't run down or need recharging. Choose the gases reacting in hydrogen fuel cell. Again, the fuel cell, the one I was talking about before, it's hydrogen and oxygen, and choose the product of the hydrogen fuel cell, it's water, H2O. The oxidation number of barium, Ba and BaF2, we can just find it. So x plus 2 times negative 1 is equal to 0, so x minus 2 is equal to 0, so x is equal to plus 2. So plus 2. Electrolysis of molten CaF2 is conducted using the following apparatus, or the below apparatus. So it's molten, okay? Identify the element produced at the cathode. So again, cathode, we have reduction, so it's the metal. And in CaF2, Ca is the metal. And at the anode, we have oxidation, and it's the non-metal. And in CaF2, F is the non-metal. So Ca and F. Write the chemical equation of the half reaction at the negative electrode. So at the cathode we have reduction. So the electrons are in reactant. So Ca 2 plus, 2 plus, plus electrons to give Ca. And to balance it here, you have 2 plus, so we're gonna need 2 E's, 2 electrons to make it Ca. So yeah, that's it. We don't need any state symbols, so it's just Ca plus 2 plus electron, you add 2 electrons to give Ca. Okay, and then they have reaction at the positive electrode. So at the anode, it's oxidation, so at the electrons are in the products. So F minus to give F plus electrons, and since F is a diatomic element, we're gonna add a 2, and to balance it, we're gonna add a 2 here. And since there's 2 electrons, we're gonna have to have 2 electrons after the arrow, so 2E minus. Okay, so 2F minus to give F2 plus 2 electrons, E minus. Drag and drop the correct answer. Concentrated solution of KBr. So concentrated KBr, and it's aqueous, right? Wait. Yeah, solution يعني aqueous. So aqueous electrolysis. So we're gonna do the questions. Okay, so at the anode, again we have the solution concentrated KBr. At the anode, is it made of Cu or Ag? No. So is it made of concentrated I, Br, or Cl? Yeah. So the equation is gonna be 2Br minus to give Br2 plus 2 electrons. So the product is at the anode, it's Br. So yeah, Br2. And at the cathode, does the solution contain C or Ag? No. So the equation is gonna be 2H plus 2 electrons to give H2. So that's the answer, H2. Okay, so H2 and Br. And then dilute solution of NaCl. At the anode, is it made of Cu? Is the anode made of Cu or Ag? No. So, and is it made of concentrated I, Br, or Cl? No, they didn't say it's concentrated. So the equation is 4OH minus to give oxygen plus 2H2O and 4 electrons. So the answer is O2. Here, O2. Okay, and at the cathode, so cathode, does the solution contain Cu or Ag? Nope. So the equation is 2H plus 2E minus to give H2. So hydrogen. So hydrogen, oxygen. And then the last one, CuSO4. at the anode, is the anode made of Cu or Ag? No, didn't say that. Is it made of concentrated I, Br, or Cl? No. So the equation is 4OH minus to give oxygen plus H2O plus 4 electrons, 2I. Okay. So oxygen at the anode, and at the cathode, the solution contains Cu or Ag. Yep. So the equation is Cu 2 plus 2 electrons to give Cu, solid. So Cu. Okay, Cu and oxygen. Okay, remember this, redox reactions are always metal plus oxygen most of the time to give metal oxide, or metal plus acid to give hydrogen plus salt, I think. So it's not this one, hey, metal plus oxygen to give metal oxide, so this is redox. And metal plus acid to give salt and hydrogen, so this is also redox. So it's only the last two options, redox, non-redox, non-redox. We're gonna have to find the oxidation numbers. NO2, oxygen is always -2, and we're gonna have to find nitrogen, so x plus 2 times -2 is equal to 0. Again, I did 2 times -2 because the oxidation number of oxygen is always -2, so -2 times 2, because we have to elect 2 oxygens, and we're gonna make it equal to 0, so x minus 4 is equal to 0. Nitrogen is +4, so +4 and -2, and here hydrogen is always +1, oxygen is always -2. We're gonna have to find the chlorine, because Cl is always -1 except when it's with oxygen, so we're gonna have to find, so 1 plus x plus 4 times -2 is equal to 0. Hydrogen is always +1, Cl we're finding it, so x, and 4 times -2 because oxidation number of oxygen is always -2, and I did it times 4 because we have 4 oxygens, and it's equal to 0, so 1 plus x minus 8 is equal to 0, x minus 7 is equal to 0, Cl is +7, so +1 plus 7 and -2. -2, oh no, -2, and then the last one, MnO4, oxygen is always -2, Mn is x, because we don't know what it is, so x plus 4 times -2, 4, I did 4 times -2 because we have 4 oxygens, and oxygen is always -2, so 4 times -2 equal to -1, because that's the charge of the ion. Yeah, so x minus 8 is equal to -1, x is equal to +7. So +7 and -2. So, yeah, -2. Okay, the process of forcing an electric current into a system of chemicals as a result of which chemical reactions that normally do not proceed is called electrolysis. You have to memorize this. Electroplating. Okay, so electroplating, it's when you want to when you want to add a layer of a metal on top of an object. Okay, so like, for example, okay, like you have to memorize how it looks like. It's basically this. Okay, so here you're trying to make this metal, like add a layer of this metal onto this object, so this spoon. So let's say maybe this is like steel, and you want to add a layer of steel on top of the spoon. And you could ask, why don't we just like dip it into steel? Okay, that would work. It would cover the whole spoon, but it wouldn't stick on that well. Maybe you could scrape it off later. This process makes the makes the steel get like really stuck on the spoon. Okay, so on the spoon we're gonna have reduction. Okay, and on the metal that you're trying to add a layer on the spoon, we're gonna have oxidation. Okay, and the solution has to be any solution with the metal that you're trying to coat the spoon with. And it doesn't have to be spoons, it could be jewelry, forks, or whatever. Okay, so next question. Yalla, plus is anode, minus is cathode, and the reaction is, again, with the metal we're gonna have oxidation, so the electrons are gonna be in the products, so this one, and the opposite in the cathode. Okay, consider the following, blah blah blah. If it's in the elementary state, the oxidation number of is 0. Oxidation number of F, it's always -1. Okay, here it's really easy, and you can know the oxidation number just by looking at it. Here Cu is +2, here it's 0 because it's in the elementary state, here again 0, and here +2. The one that lost electrons is the one that has a higher oxidation number, so Zn went from 0 to +2, so Zn lost electrons, and the number of electrons lost is how high the number is now, because it was 0 and then it went to 2. So electrons lost is 2. So Zn and 2. Yeah, let's submit. Bismillah. Yep, okay. Thank you guys for watching. I hope you had a great holiday, and good luck on the periodic